Hi guys, welcome back to my YouTube channel. This is Tanushree. Okay, in my Laplace part 1, part 2, part 3 videos which are going to be explained about the Laplace transform. So in part 1 I am going to explain about some elementary functions with their proof, and in second part I solved the problems on that elementary functions, and in third part I am going to explain one proof with their important formulas which are going to be used in some problems that I solved in that previous video. Okay, so in this video I'm going to start the important theorem on the Laplace transform. That is it is based on the definitions of the Laplace transform only. So the whole theorem which will be based on that definition of Laplace transform. So today I have taken the two theorems. In this video I'm making two theorems proof. Okay, in the next video I'm going to solve the problems on that proof with their important steps. Okay, so please do subscribe to my YouTube channel and click on the bell button icon that will notify you for my upcoming videos. So let's start the video with the first theorem. That is, if L of f of t is equal to f of s, then L of f of t by t is equal to integration over s to infinity f of s into ds. So we have to prove this theorem with using the definition of the Laplace transform. Okay, so what was the definition of the Laplace transform? That is, L of f of t is equal to f of s is equal to integration over 0 to infinity e power minus st f of t into dt. So some basic definition I had told in my part 1 video, so you can watch that video. It is linked in the description box, so you can go through that, then only you can understand the next videos, okay, on the Laplace transform. Okay, what we have to do, we have to prove this what we can say, some proof. Then what we have to do, we have to multiply the integration over s to infinity to ds on the both side, then we will get this RHS. Okay, so we will multiply this to the definition of the Laplace transform. Here we are not considering L of f of t because L of f of t is equal to f of s only. So we are considering the f of s is equal to integration over 0 to infinity power minus st f of t into dt. So it is LHS and it is RHS. So we have to multiply the integration over s to infinity ds in order to get the proof in the both LHS and the RHS side. What we have to do, so when we multiply this, what happens in the LHS, integration over s to infinity f of s into ds is equal to integration over 0 to infinity into integration over s to infinity e power minus st f of t dt into ds. So this is what the multiplication we did, and what we have to do, we have to make the t terms one side and s terms another side. Okay, here t terms, what are their f of t into dt, this is the t terms and it is s terms with their integrations. Integration over 0 to infinity f of t into dt into integration of s to infinity e power minus st into ds. So we will take as it is term and we have to integrate with respect to s. What we get, e power minus st, what is the coefficient of the s is there, minus t, right? So we have to take the minus t in the denominator. While we are doing in the differentiation, what we get, we will put the coefficient of that derivative in the coefficient or in a multiplicative form or a numerator. So while we are integrating, what we have to do, we have to put the coefficient in the denominator. We will study it in the differentiation and integration topics. Okay, that is a general basics for this. Okay, then what we have to do, we have to apply the limits. Okay, first we apply the upper limit. E power minus infinity means 0 minus of e power minus st as it is. Okay, because here limit is s. Okay, we have to substitute the s and infinity to the s term. Then e power infinity is 0 minus e power minus st. So minus t, here minus minus get cancelled. What we get is e power minus st. So we can put the t in the denominator of the f of t. Okay, so because it is a multiplication form, so we can transfer it from denominator f of t or e power st, either we can do that. Okay, so I will write it as f of t by t. Okay, integration over 0 to infinity e power minus st f of t in divided by t into dt. So this is in the form of the definition of the Laplace transform. As we know, integration over 0 to infinity e power minus st f of t into dt. What is the f of t here? F of t by t. So we can write it as L of f of t by t. So we will got the LHS, right? We get the LHS and we get the RHS. So the proof we get it is integration over s to infinity f of s into dx is equal to, this is it can be written as what? L of f of t by t. This is what the proof of this first theorem we had proved. Next we will move on to the second theorem. Okay, in this theorem we're going to prove in the multiplication form. In the previous theorem we had proved in the denominator, like dividend. Okay, dividend f of t we had proved here. We have to prove in the multiplication form, that is t power n into f of t is equal to what it will be proof, that is minus 1 whole power into d by ds whole power n f of s. So we have to prove this statement using this definition of the Laplace transform with the what was the order here, n, right? So we have to prove for a n, so we have to prove for n, then we have to prove for a n is equal to 1 first. Okay, derivative for a 1, then we have to prove for a k. Okay, if it is to verify for n is equal to 1 and to verify n is equal to k, and after to verify n is equal to k plus 1, then by verifying these three steps we will get to verification of n also. So we will move on through the steps. Okay, so for proof we have to take the first definition of the Laplace transform, that we know f of s is equal to integration over e power integration over 0 to infinity e power minus s t f of t into dt. So what we have to differentiate this equation to prove for n is equal to 1. Okay, so if we differentiate, what we'll get, if f of s differentiation means f dash of s is equal to f dash of s, which can be written as d by ds. Okay, d by ds of f of s is equal to integration over 0 to infinity e power minus st, right? Then f of t. Okay, what will be the differentiation of e power minus st with respect to s? So there will be s, so we can differentiate with respect to s. So here not at all any s's are there present, so we will put these terms as a constant. Then we are going to differentiate the e power minus st. What will get e power minus st? So what was the coefficient of the s is there? Minus t, so multiply by minus t, okay, into f of t into dt. Then what will get here, minus 1 taken common. Okay, that cannot be integrated. Okay, so we will taken common minus 1 as it is, and what with the remaining, it will be written as it is, that is integration over 0 to infinity e power minus st t into f of t into dt. Here minus 1 to get the RHS, it is in the form, so what we have to do, we have to multiply this minus 1. Okay, we have to multiply the minus 1 to the both LHS and RHS, then we get here minus 1. Okay, minus 1 d by ds f of s, that we got the RHS. So now we have to prove for n is equal to 1, and that we will get to LHS 2. Okay, so then what was the remaining here? So when we multiply the minus 1, what happens here? Minus 1 comes, minus 1 into minus 1, what? Plus 1. 1, there is nothing but 1 only. Okay, so integration over 0 to infinity e power minus st t into f of t into dt. So what was the order here? 1, right? There is nothing means there is a 1. Okay, so it is true for n is equal to 1. Okay, there will be true for n is equal to 1. So next we have to verify for n is equal to k. So again differentiating the definition of the Laplace transform that we got, and by differentiating with respect to verify the n is equal to k. So by differentiating, what is the differentiation of f of s? D by ds f of s. To verifying n is equal to k, then we put the power k. Okay, to verify for k. Then integration 0 to infinity e power minus st. Differentiation of e power minus st into t means what? S into t means what? E power minus st. What was the coefficient of s? Is minus t whole power k, because we are verifying for n is equal to k, f of t into dt. Okay, then we will take the minus 1 as a common term, and we will multiply the minus 1 to the both LHS and RHS term. Okay, I will show you. Yes, in this step here, minus 1 taking a common, right, which cannot be integrated. Minus 1 whole power k is taken common, and e power minus st t power k f of t into dt as it is. Okay, then what we have to do, we have to multiply the minus 1 on both sides. Minus 1 whole power k on both sides, what will get? It will get it as minus 1 whole power k as it is, multiplying to the LHS. When we multiply to this, what happens? Minus 1 into minus 1 plus 1. So 1 power k, 1 power anything will be 1 only. So we are not considering that. Okay, integration over 0 to infinity e power minus st t power k into f of t into dt as it is. Okay, so it is true for n is equal to 1. Okay, it is in the form of what? Laplace transform definition, right? That is L of t power k into f of t. Here f of t, which will be replaced by t power k into f of t. This is what the definition of the Laplace transform. So we got the second theorem proof for n is equal to k. Next we will get that proof for n is equal to k plus 1. So we have to consider this required equation for the proof or verifying for n is equal to k plus 1. Okay. Next, verifying for n is equal to k plus 1. So we have to consider the second equation which is required for n is equal to k verifying. Okay, that time required equation which is very important to carry on the verification for n is equal to k plus 1. So we have to differentiate the equation 2 with respect to s again to get the proof for n is equal to k plus 1. That is, we have to integrate this. I will show you here. So what will happen if we it is a constant, right? It cannot be differentiated, so it taken as common right now. And this differentiating this term, what happens? K becomes k plus 1, right? Okay, if we differentiate one order, what will be again differentiation? It will requires d square, right? Like that only. 1 plus 1 2, right? So that is the same in case of the k also. Okay, we will differentiate it again. What will happen? The power only changes, that is k to the k plus 1. Next, we are differentiating this RHS term, integration over 0 to infinity e power minus st. Here t, what is the coefficient of s is minus t, right? Minus t into t power k f of t into dt is put it common because there is no s term to differentiate. Then what will happen? Here we have to take the minus 1 as a common term. Same thing that we did in 2 verification. In that way, steps we are verifying for n is equal to k plus 1. Okay. We are taking minus 1 as a common term. Then we multiply the minus 1 on each LHS and RHS. What happens if we multiply minus 1 to this LHS? What happens? Minus 1 will add it. Okay. What was the power of this? 1. Okay. When base is same, we have to add the power. K plus 1 becomes, right? Then we have to put the same as it is. And here what we have to do? We have to multiply the minus 1. So minus 1 to minus 1, what happens? Plus 1. So 1. 0 to infinity. Integration of 0 to infinity e power minus st t power k plus 1 here is there. Okay, this is t power k. So here 1. Okay, base or same, we have to add the k plus 1. Minus 1, it will be taken common as I told you. T power k plus 1 into f of t into dt, which will be in the form of the Laplace transformation definition. That will be written as t power k plus 1 f of t. Here f of t, which is replaced by t power k plus 1 into f of t. So it will be proved for the n is equal to k plus 1, right? So by equation 2 and 3, okay, that we got for equation 2 for n is equal to k and equation 3 for n is equal to k plus 1, it is proves that n is true for a 1 and k plus 1. Then we can easily say that it is a true for n. Okay, so therefore L of t power n into f of t is equal to minus 1 whole power n into d power n divided by ds power n into f of s. So on this basis and on this 2 theorem, we are going to solve the problems on the next video. Okay, I will use these formulas for solving the problems which is in the form of t power t into f of t, and another form that I told in my first proof, that is f of t by t. So we are getting the problems on this basis. So by using these substitutions, we can easily solve the problems. So I think it will helpful for you and it may understood or not. So please let me know and comment me in the comment section box. Okay, thank you for watching this video. Please like, share and comment on this video.